Alright, Chapter 2, Creating Solids. Introduction to solids. 2.1. 2.2. Creating solids using basic shapes. Box command, cylinder command, cone command, sphere command, pyramid command, wedge command, torus command. Editing basic solid shapes using grips. You edit basic solid shapes using quick properties and properties. 3D object snap. Practice 2.1. Basic solid shapes object snap. 2.6. Using Boolean functions. Union command, subtract command, intersect command, solid history. Using press pull command. 2.7. Practice 2.2. Boolean functions and press pull. 2.8. Sub-objects and gizmos. Culling. Subject selecting cycle. Selecting user preset views. Using gizmos. Practice 2.3. Subjects and gizmos. 2.1m. Mechanical project using metric units. 2.1.1. Mechanical. 2.1i. Mechanical project using imperial units. 2.2m. Architectural projects using metric units. 2.2.3 M mechanical project using metric units. 2.2.3 I mechanical project using imperial units. Chapter review answers. Alright, Chapter 2, Creating Solids. In this chapter, with its all basic shapes, manipulating solids, press pull command, 3D object snaps, and sub-object gizmos. Introduction. Solid works on 3D objects with a containing face, edge, vertex substances inside the most accurate 3D objects because they have all the physical information. There are many ways to produce solids in Autocad. Here are some of them: creating 7 basic solid shapes, creating complex solid shapes using Boolean operations, union, subtract, and intersect, creating complex solid shapes by converting 2D objects using press and pull command, creating complex solid shapes using sub-objects and gizmos. 2.2. Creating solids using basic shapes. AutoCAD provides 7 basic solid shapes. Basic shapes will be our first step to create more complex shapes. To find all these commands, go to Home tab, locate Modeling panel, and select one of the following. You have box, cylinder, cone, sphere, wedge, pyramid, torus. Here's a discussion of each command. Alright, 2.2.1, the box command. The command will allow you to create the box or cube. Choose box command format. Following prompts you will display specify first corner or center. Specify other corner or cube length. Specify height and or 2 point. To draw the box in AutoCAD, you have to define the base first the height, and then the base will be drawn on the correct XY plane. Here are some variations. Specifying base and type coordinates of the first corner and of the coordinates of the opposite corner. Specify the base type of the coordinates in the first corner to specify the opposite corner. Specifying length and height using N tab key. Specify the base by typing coordinates of the first corner type to specify with the opposite corner. Specify the length and height using the typing and the tab key. Specify the base and specify first corner and length to specifying x in axis direction, width in the y-axis direction. Specify the base of specifying the first corner, then specify with the cube option. AutoCAD will ask you to input one dimension for all sides, length, width, and height. Specify base and specify center point, one of the corners of the base. After specifying the base, specify the height either by typing or using the mouse, or by specifying 2 points by clicking, and then this is a good method if you have an existing object. So here we looked at a cube. From now on, you can have the dynamic input to input all any of the distances needed to complete any command. 2.2.2 Cylinder command. The command will allow you to create the cylinder and choose cylinder command. The following prompts will appear. Specify center base point at 3.2 point, tangential radius, electrical, tangent tethered radius, elliptical. Specify base radius or diameter. Specify height or 2 point axis endpoint. Draw a cylinder in AutoCAD. You have to define the base first, then the height. Here are some of the variations. Base could be circular or ellipse. The option to draw either circle or ellipse will be identical with the 2D prompts. Base will be drawn on the current XY plane. After defining the base, specify the height either by typing or using the mouse. By using 2 points option, either the height or an existing object. End option. Axis end option will allow you to rotate the cylinder by 90 degrees to make the height of the XY plane not perpendicular to it. Using polar unit, and you can be directed with the cylinders as you wish. So we made our base and then we've pulled it and rotated it 90 degrees at the axis. Cone command. Cone command will allow you to create a cone that chooses the cone command and following prompts will display. Specify center point over the base, 3.2 point, tangential radius, elliptical. Specify base radius or diameter. Specify height or 2 point axis, end point, top radius. Cone and cylinders are identical prompts, hence they will not discuss them again except for the one thing. For one thing, the cone command will allow you to draw a cone with a top radius. Sphere command. The command will allow you to create a sphere. Choosing a sphere command following the prompts will appear to specify the center point, 3.2 point, tangential radius, specify radius and diameter. The prompts identical. Circle command prompts 2.25 pyramid command. Command will allow you to create a pyramid. Choose the pyramid command following the prompts will appear. Four-sided circumscribed. Specify center point of base, edges, and sides. Specify radius, base radius, or inscribed height. Specify height or 2 point axis, end point, top radius. Default is 4-side base. You can change the number of sides by selecting side option. Draw base. The same method for drawing a 2D polygon. Height options were discussed in previous commands. These examples below are 4-sided base for the top smaller polygon. Alright, 226, the wedge command. The command will allow you to create a wedge. Choose the wedge option. The following prompts will be displayed. Specify first corner center. Specify other corner cube or length. Specify height or 2 points. And then it shows the prompts are identical to the box prompt. And in fact, with the wedge is part of the box. Is part of a box. If you have to define the base first, then to define the height, the wedge will be XZ, YZ plane toward the X-axis. So here's a wedge. 227, a torus command. The command will allow you to create a torus. Choosing the torus option following prompts will appear. Center point, specify center point, 3.2 point, TTR. Specify radius, diameter, tube radius, and specify tube radius or 2 point diameter. Specify center and radius diameter of the torus, and specify the radius or diameter of the tube. Check the following illustration. So we did the tube diameter and torus diameter. 2.3 Editing basic solid shapes using grips. If you click one on some of the basic shapes, depending on the shape, you will see grips on the center place. These grips will allow you to modify the dimension of the basic shape in all directions. Here's a box grip. So these are the grips, what the grips look like. Here's a cylinder grip. Here's a cone grip. Here's a sphere grip. Here's a pyramid grip. Here's a wedge grip. Here's a torus grip. In all above cases, we can see that the grip of the rectangular shape and the arrow of the triangular shape of the grip will change 2 dimensions in one shot. Check the following illustration. So we can see with the rectangular shape and the arrow with the triangular shape, the grip will 2-dimension one shot, and check with the following illustration. Yeah, the arrow will change dimension one direction like the following, and then it shows, you can use both cases if there's more than one dimension to the input. Use the tab key, jump from one to another. Using grips, arrows known to dimension, edges, shape, check the following illustrations. Alright, 2.4 Editing basic solid shapes using quick properties and properties. As much as we can edit with the basic shape graphically, we can edit these dimensions with the quick properties command. When you click the basic solid shape once, quick properties will come up with automatically. Check the following illustration. Shift the color layer, elliptical radius, and height, and that's a 3D solid. The above is a cylinder shape. You can change with the radius and height. Change the base from being a circle to an ellipse. Elliptical, to activate the property, select the desired shape, right click, then select the property option. You'll see something like the following. 3D solid, general color, layer, line type, scale, plot type, line, weight, transparency, hyperlink, visualization material by layer, solid type, position X, Y, Z, elliptical radius and height, solid history, and show history. At the top, you'll see a 3D solid. Under the geometry, you'll see a solid type. In our case, it's cylinder. You can edit this piece of information. You will also see the list of geometry values, which can be edited and modified as desired. 2.5 3D Object Snap. The 3D Object Snap is over the object snap, but only with 3D objects. It will help you hold on to 3 objects. As first step, you have the switch to 3D Object Snap on and off from the status bar. So the snap cursor to 3D references on 3D Object Snap, 3D Object Snap F4 key F4 shortcut key F4. Command name 3D OSnap. Right clicking on the button will display the 3D OSnap, and from which can be distinguished over the active and inactive ones. Have vertex midpoint on its center face not and perpendicular nearest to the face object snapping settings. Select the settings option. You will show the following dialog box: snap grid, polar track object, 3D object snapping. 3D object snapping on shortcut key F4, vertex midpoint center face not, perpendicular nearest to face, point cloud, node intersection edge corner, nearest to plane, perpendicular edge center line. OK, cancel, help. You can turn on and off the desired modes. You have 6 modes to control. You can snap to a vertex. You can snap to a midpoint on the edge. You can snap to a center of the face. You can snap to a knot or a spline. You can snap to a point perpendicular to the face. You can snap to a point very nearest to your selected point. Practice 2-1. Basic solid shape 3D object snaps. Start AutoCAD 2009. Open practice 2-1. Drawing file. Create pyramid with 4 base sides. Circumscribe radius 30 top. Side radius 115. At 15, height at 25. Using cylinder command on 3D object snap, specify with the base of the cylinder, center of the top side of the pyramid, using radius equal 10, height 850. Drawing another cylinder top, first one, radius 2.5, height 75. Empty space, drawing box length 60, width 2.5, and height of 30. Using move command, 3D object, 2D object snap, move the box to the upper cylinder to get the following results. And it kind of looks like a flagpole. Using any of the edited methods, learn change of the radius of the top cylinder to be 5, change of the width of the box 5, save and close. Using Boolean functions 2-6. This is our first method to create complex solid shapes. The Boolean 3 function union, subtract, and intersect with this issue commands go for the home tab, locating solid editing panel. The 3 buttons to the left of the target are shown below. So we have your solid editing panel, extract edges, extrude faces, separate. The union command. The command will allow you to union all selected surface solids and surfaces in a single object. You can pick up the objects in order you want. Then press and enter. Check the following example. And now we've made before union and after union. Subtract command. The command will allow you to deduct volume solids for existing volume. Picking objects using should be pick up the objects to be deducted from first. When picking objects, you should pick the objects to be deducted from first. Then press enter. Then pick the objects to be deducted. Then press enter with the command. Check the following example. Before and after subtraction. 263 intersect command. Command will find and create the common volume between 2 solids or more. Pick solids in any order you want. Check the following example. Before intersection, after intersection, solid history. Big question is, does AutoCAD remember the original basic shapes contributed to create the complex solid? The answer to the question is yes. In order to succeed with the matter, you should use the following steps. Before creating complex solid shapes, go to Solid tab, locate primitive panel, select Solid History button if it was not selected already. Solid history, as in the command solid HIST, set default history prompt setting with the solids for solid objects. Create your complex solid shape, select the complex solid active properties palette. Under the solid history, make sure that history equals record. Check the following illustration. Solid history equals record, show history, none. Now hold the control key, hover any of the part of complex solid, the original object highlighted accordingly. You can select them, and it will engage the grips to appear, and hence you can edit the geometry values, checking the following illustration. Using properties, if you see that the show history equals yes, all solids contributed to create the complex solid will be displayed, but unfortunately user can't edit them in the state. To them, you need to hold the control key as we did in the previous tab. Check with the following illustration. 2.7. Using press pull command. The press pull command is a very handy command which will help you to create the 3D solids on the fly. User can do one of the following procedures. Press pull, offset existing face of 3D solid depending on the mouse movement. The volume of the 3D solid will increase or decrease After drawing a 2D shape on the face of the 3D solid with a press pull command will allow you to create a 3D solid of the union and subtract it from the existing 3D solid. Use a closed shape 2D shape press pull creating 3D solid. Use open 2D shape pressing and creating 3D surfaces discussed in Chapter 4. Press pull command has multiple options. User hold down the shift key instead, which will allow them make several push pull movements at the same time. To issue the command, go home tab, locate modeling panel, select press pull button. And the command is press pull. Press pulls bounded areas. You'll see the following prompts. Select object of bounded area, select extrusion height or multiple. Command will keep repeating the 2 prompts until you end it by pressing enter. Here example the 4 cases. The first case, you with the press pull command to the offset 3D solid face. Specify the extrusion or height and then you have the little X mark in your triad. Second case, after drawing a 2D object, 3D solid face, you can press pull the 2D shape and add or remove the volume tool 3D solid. Third case, press pull close with the 2D object, produce the 3D solid. Fourth case, press pull open 2D object to produce 3D surface. Fourth case, press and pull an object to produce a 3D surface. And then using multiple options, you can hold the shift key instead will allow you to select several of the objects, open the 2D, close 2D, face 3D solid, and press pull them in one shot. You can use the control key to control output with the command. Let's see the following example. Without holding the control key, and then we can have the holding the control key. In the upper case, you can see that the press and pull offset of the face perpendicular over the existing face. Hold following while holding the control key, press pull offset to the following taper angle. Bowling 2-2. Bowling functions press and pull. Start Autocad 2019. Open practice 2-2 drawing file. Select with the big box. Right click. Select property. Change the value of the history record. Change the properties palette. Subtract open cylinder from the box. Subtract lower cylinder from the box. You have 2 different commands. Union of 4 boxes. Edges with big boxes. Hold control key. Click upper cylinder with the grip show with the chain with a radius of 30. This is 10 units of the current radius. You have the same technique for the lower cylinder, 10 units only, but that is remove the 10 units from the current radius. Use press pull command pulling 2 upper sides up to 20 units using press pull command press front side inside by 15. You'll get something looking like the following, and it shows follow layer 2D objects using press pull command pull the closed shape of the XY panel play up to 60 units. Using press pull command, press with the 4 circles edge of the remove them from the volume shape that you need to either subtract. You need to use subtract even the press pull command pull with the 2 rectangles left side with the outside with a distance of 15. Using press pull command pull the open shape up by 60 units. Select the new shape of the type of the shape. This is the final shape. Save and close file. Alright, 2.8 sub-objects and gizmos. A sub-object is any solid part of a solid that it can be a vertex, edge, or face. Gizmo is a gadget that will help you. Alright, move and rotate and scale selected vertex, edges, and face. Both available in the Home tab, the selection panel. Alright, show the culling, no filter selection gizmo. You have move gizmo, rotate gizmo. Scale gizmo, no gizmo, and then you have a filter, vertex, edge, face, and your sub-objects and filter, vertex, edge, face, solid history, drawing view component. You can specify the filter gizmo using status bar, but without no filter, no gizmo options like the following: vertex, edge, face, and solid drawing history. Solid history and drawing view component on the right, and then move gizmo, rotate, scale, and gizmo. First is to select the desired type of the filter. Your course is to change the below shape. The cursor is selecting the vertex. Now, whenever you select, you will select only sub-objects you choose. So, for example, the sub-objects, you have vertex, edges, and faces. Which you're selecting there are 3 things that you can take care of it and are the following: culling. Culling is a feature very useful tool. Allows you to select only sub-objects visible with the current viewpoint. To switch it on and off, go to Home tab, locate selection panel, and then click Culling button on and off. Or the culling object, whether the objects are hidden from the view or highlighted when you roll over them. The command is culling obj, and that's a F1 for more help. Culling buttons is off. It means that the sub-objects will be selected in spite of whether they are visible or not from current viewpoint. Checking the following two examples. So we've done culling is on, and now we have all these edge points. Culling off, you have a different set of edges. Selecting cycle. When you click on a face to select what you may have with the other face behind it, with the Autocad will allow you to pick exactly what it intended to select. With the Autocad will show you the small window called the selection. It includes all objects that exit the same space for the click. Small window will change from the one object to another. You click the desired one. The feature is called the selecting cycle to deactivate the drafting setting dialog box, which we use snap, grid, O snap, or so on. Select the selection cycling tab just like below. We went to drafting settings. We've now looked at selecting cycle, allowing selecting cycle, selection cycle, display selection and listing box, cursor dependent, quadrant, bottom right, distance in pixels, static and show bar, and then options, OK, and help. Here's an example. Let's assume that you have a pyramid and we click the top of the face as shown, and we've now done our selection. And it shows solid faces 1 and 2 and none. Autocad will select the nearest face to your click, but it will allow you to select the face behind it as well, or leave it if you decide. Check the following illustration. This applies to edges as well. 2A3, selecting using preset values. Use only preset values will enable you to select multiple sub-objects. Quickly accurate following steps will clarify the concept. Clicking and culling off using view cube, going to the top view from sub-objects panel, selecting edge. Without issuing the command, the window containing the edges after the right side of the left side of the box, just like the following. Using view cube, changing the 3D preset views will see something like the following. Alright, using a gizmo. After selecting the desired sub-objects, you can choose the needed gizmo to change sub-objects. There are 3 gizmos to select: move gizmo, rotate gizmo, scale gizmo. So once again, that is move gizmo, rotate gizmo, scale gizmo. By default, gizmo will be the last selected sub-object to go. Move gizmo from the last sub-object to another. Move your cursor without clicking it. To desired sub-object, stay with a couple seconds. Gizmo will follow. You'll see the following menu. Right-click. Move, rotate, scale, set constraint, relocate gizmo, align gizmo with custom gizmo, respect dynamic unit coordinates, user coordinate system. This menu will allow you to change the gizmo command, set the constraints, will set the axis plane to be used, relocate, align, customize gizmo. Move the gizmo consists of 3 axes. Move the selected sub-objects along with one of them, namely X, Y, and Z, along the plane. 2 of them, X, Y, Y, Z, and Z, Y, X, Z. To this, however, one of the 3 axis highlights, it will become golden, and click and move. Use the right-click menu to set the desired axis using constraint option. Click in the following illustration. Rotate gizmo consists of 3 circles. To rotate one of the 3 axes, move the cursor to the desired circle and pause a couple seconds. Using until the highlights and becomes golden, then click the rotate. You can use the right-click menu to desire using constraint option. Check the following illustration. Scale gizmo consists of 3 axis scales. Helps you select the X, Y, Z, Y, Z, and X, Z, or spaces X, Y, and Z. Move the cursor to the desired point. Cause for a couple of seconds. The plane highlight will become golden. Click the scale. You can use the right-click menu to desired axis using the constraint option. Check with the following illustration. Gizmo will act not only on sub-objects but also solid shapes following the following steps. Make sure the sub-object filter is equal to no filter. Make sure the culling is off. You can also see all the grips. When you click the solid shape gizmo will appear in the center of the shape. It will be base point. Your base point. If you want to use other base points, relocate gizmo, selecting the other grip of the new base point. Serve as desired command, execute. Check the following illustrations and Practice 2-3 sub-objects and gizmos. Start AutoCAD 2019. Open Practice 2-3 drawing file. Seeing sub-object face, move with the upper face 5 units up. View the same face, rotated to X in red circle 15 degrees. Select the edge shown, move with the outside 5 units. Rotate shape within C with the curved face back. See with the curved face at the back. Select with the curved face, scale with a 1.5 factor. Select with the 2 vertices shown, moving them down to right 5 units. Save and close file. Alright, we're going to skip them. Well, let's go ahead and read it. 2-1 mechanical project input. Start AutoCAD project 2-1M drawing. Draw 3D solid using following information. Final shape should look like the following. Save and close. 2-1 mechanical project imperial units. Open project 2-1I. Drawing unit should be the following, and then it should look like the final shape should look like the following. Save and close file. Project T2M architect project using metric units. Project start AutoCAD 2019. Open project T2M drawing file. Make sure visual 2D wireframe. Create a new layer called 3D wall. Set the color to 9. Make it the current. Use press bold command. Press outside wall up to by 3,000 units. Making sure the door and window opens and kept. Create a new layer called 3D door. Set the color to be 8 and make it in the current. Draw the outer depth of the door jamb. Explode with the 2D door block with a press pull. 2 rectangles representing jab up by 2,000 units. Close with the frame. Draw out of the box and 2 ends of the 2 boxes. Just pull with the height of 50. Using union command, union of frame to be one piece. The draw is open and will be open. Erase the arc. Increase the length of the inside line by 1 unit to make the 2 lines length of 800. Draw line closing shape. Use the pull command. Rectangular 2,000 up, creating the door. Make a layer of 3D wall current to close the gap between the door and the wall. Draw with the arcs. Using object stamps. Using union command, union wall to one piece. Move the 2D block of the window right door. Using press pull with the rectangle to place the 2 window blocks by up to 500 units. Creating a new layer. Name units 3D window. Set the color to be 8 and make it current. Explode with the 2D block window. Erase the inner 3 lines. Press the 2 rectangles up by 1900, creating the 2 boxes, 2 ends of the height, and 50 to close the frame. Union 4 boxes, create 1 unit, move it to open, make the layer 3D wall come to create the box, close with the gap as you did in the point 12. Copy the 3 point parts with all the windows in the same size. Do the same with the big windows using window height of 1500, 1400 plus 50 plus 50. The distance of the ground from being in the window still height is 1000. Using union command, union hold walls, freeze layer, A wall, A door, A window, create a new layer, 3D roof, set it color to be 8, make it in current, create a wedge base of 2350 by 11,400 with height of 2,000, mirror around the longest dimension, union both parts, move the gable to the top of the wall of the entrance, create with the second gable to create a wedge base of 3,675 by 7,600, which have the height of 2,000. Mirror used along the dimension, union them, rotate the gizmo to make them either part of the roof, move the gable to the top of the walls. Take and make 2 gables close right, change the subject of the vertex, select the top vertex right, just like the following. Now you have a house. Using the gizmo, move the touch of the other gable, and you may need a particular object snap. It should look like the following. Create a new layer called 3D base, set its color to be 8, then make the current look at the model from below. Using object stamps model, create the box covering the area. House height with an navigate 50, select with the base show with the grips. Use the grips of the side of the entrance, make with the dimension to be 220,000 units from the other 3 side with the dimension 3,000 units. Create the new layer called the 3D stairs. Set the color to 8, make it the current, and an empty space in place create with 10,000 by 275,500 with height of 200 in the negative. Move it in the midpoint, top of the edge, midpoint with the base from the entrance side. Copy the 4 times with create the staircase going down. Create a box of 18,300 by 15,000 height of 50 with a negative. Move it to midpoint last step. Create a new layer called the 3D entrance. Select with the color 8 and then make with the current start with the cylinder command. Set with the center point, midpoint, right edge of the last box drawn with a set radius 500 width of the with a height of 6,000. Move to the inside of the file by using 500 using Gizmo. Copy the on the other side. Use the 3D stamp. Copy the inside interface to make the total of 3 cylinders. Empty the spacing. Draw a box of 8,650 by 55,250 with a height of 900. Use the dynamic user coordinate system. Draw an arc upper face with the start center end where the start of the lower right endpoint starting with the midpoint lower edge endpoint with the arc of the other endpoint of the edge. Use press pull of the arc draws downwards to subtract it from the shape. Use the gizmo, rotate the shape from the 90 degrees. Move the shape of the midpoint center of the cylinder. Copy to the other side using both shapes. Use the final state. This is your final shape. Now we have a house with an arcway and save the file and close it. Alright, project 221. That's another same thing in a house, but imperial units. Mechanical project unit, metric unit, start Autocad 2019. Open project 2D3 mechanical drawing. Metric units, draw 3D shape of the following information and missing dimension on the top right image of the 2. The final shape of the 3D should look like the following. Save and close. Mechanical project using imperial units. Same thing. Missing dimension shape top image 112. Final shape 3D should look like the following. Save and close file. Notes and chapter review, questions, answers. Chapter 3, creating meshes.